Hello, welcome to Applied Chemistry lab videos of IPCC course. Myself, Dr. Kiran Kumar P, Assistant Professor, Department of Chemistry, ATME, College of Engineering, Mysore. And today's experiment is on estimation of total hardness of water by rapid EDTA method. So the experimental demonstration includes the theory of the total hardness of water, followed by experimental demonstration, and lastly, we see the observations and calculations. So total hardness of water is the amount of calcium and magnesium concentration. I mean to say the calcium and magnesium ions present in the given water sample. So the hardness of a water is expressed in terms of milligrams per liter. You can see here there are two different glasses which has a water which is filled with water. One is having soft water, another is a hard water. The reason for the softness in water is due to lesser ions of calcium and magnesium, whereas the hard water has more amount of calcium and magnesium ions. So the calcium and magnesium ions may be in the form of salts of calcium carbonates, chlorides, sulfates, bicarbonates, magnesium carbonates, etc. So a hard water is typically which is above 180 milligrams per liter is considered to be a very hard water. Similarly, the water which has in a range of 0 to 60 milligrams per liter is considered as a soft water. So the total hardness is classified into two types, permanent hardness and temporary hardness. So both hardness, the hardness, the typically the two types of hardness is classified based on the salts that has been dissolved in it. Generally, the temporary hardness is due to the presence of carbonates and bicarbonates of calcium and magnesium. Where why the reason they called as temporary hardness is through simple boiling process we can remove their hardness, whereas the permanent hardness is due to the presence of chlorides, sulfates of calcium and magnesium salts, which cannot be easily removed through simple process. It requires the ion exchange method and distillation method. So these are the drawbacks that are caused due to hardness, excess of hardness in water. Let us have a demonstration of total hardness of water. So the chemicals required for estimation of total hardness of water is we need a EDTA salt, disodium salt of EDTA salt, ammonia. Since EDTA is sparingly soluble in water, to increase the solubility, we use ammonia. Also, we need a sample, hard water sample, and a buffer, and the indicator EBT, Eriochrome black tea. We need a weighing machine, weighing balance, and the apparatus required are we need a burette, standard flask, conical flask, funnel, measuring cylinder, and wash bottle. So typically, the initially, since we are dealing with hardness of water, it is mandatory to wash all the apparatus with distilled water to avoid the contamination of hardness present in a tap water. So all apparatus are rinsed with distilled water. Including the standard flask. The conical flask, funnel, After washing it thoroughly, after washing it thoroughly, the estimation of total hardness of water has two parts in it, part A and part B. Part A is the preparation of a standard solution of EDTA, disodium salt of EDTA. In order to do that, weigh a known weight of disodium salt of EDTA. Note down the weight of salt plus weighing bottle in the observation provided. Transfer the salts into the standard flask and note down the weight of empty bottle. So that gives, if you subtract these two, you get a weight of salt transfer. Now, EDT is sparingly soluble in water, hence we need to add ammonia to increase its solubility. Then add distilled water along the sides of the funnel. Make sure all salts have been got into the standard flask. Dissolve the salts. Dissolve the salts. Once it is dissolved completely, add water, distilled water up to the neck. Now the remaining water to be added from burette up to the neck. Now invert the flask and mix the solution well to obtain uniform concentration of standard solution of disodium salt of EDTA. Now calculate the normality using the given formula. Now you have prepared the standard solution of EDTA. Rinse the burette with prepared standard solution of EDTA. Now we shall move on to part B, estimation of total hardness of water. In order to do that, fill the burette with disodium salt of EDTA, standard solution prepared. Now pipette out 25 cm cube of hard water sample into the conical flask. Transfer it into the conical flask. Now add buffer solution, 5 to 10 cm cube of buffer solution, which maintains the pH. Since during the reaction process, there will be evolution of H plus ion, which will be decreasing the pH of a solution. Hence, it is mandatory to add the buffer, base buffer. Now add EBT indicator. A pinch of EBT indicator is added. The hard water has calcium and magnesium ions. The added EBT indicator reacts with some amount of calcium and magnesium ions to form the wine red color. The wine red color is due to the presence of the complex between the calcium and the EBT. Now titrate the note down the initial reading and take the solution against the standard solution prepared. Carefully titrate it till the color changes from wine red to clear blue color. So this clear blue indicates the the EDTA has been completely reacted with the calcium and magnesium ions present in a sample. So this is how the color changes. So the indicator will be free, hence it imparts blue color. So such titration to be carried out until you get a concordant reading. Once you get a concordant reading, you can find out the total hardness of water in ppm. So this is what it is, the observation and calculation part. The part A is the preparation of standard solution with the help of the weight sample taken, transferred into the standard flask, you get a molarity. Once molarity is determined, the part B is conducted with the help of the indicator EBT. The change in color, wine red to clear blue, indicates the endpoint. Now, with the help of concordant reading, you can calculate the total hardness of water, which will be measured in terms of ppm, parts per million.